When we're thinking about forces between objects, the first thing that we probably want to do is to check that we know what we mean by a force. So forces change the shape motion or state of rest of an object. Okay, so let's think about what this actually means. So when we're talking about forces changing the shape of an object, we're talking about it being stretched or squashed. Okay, so if we've got a spring and we apply force to the spring, then we're going to stretch the spring. If we've got a stress ball and I apply force on it, then I'm going to squash it. Okay, when we're talking about motion, we're talking about, are we speeding it up, slowing down, or changing direction? Okay, and then state of rest. And what we mean by state of rest is whether it is stationary or not. Okay, so I guess it's important as well at this point to add that forces are measured in newtons. So that's the unit for force. The symbol that we use for force is F. The symbol that we use for newtons is a capital N. That's useful for when we start to do equations using force. So some forces, we need to know names of different forces. So some forces need to touch. And these are called contact forces. And examples of contact forces are things like friction and air resistance, which we could call drag together. Tension, so when you apply a force to stretch something, and then something that you might not have heard of before, but you will have encountered, a normal contact force. Okay, and this comes up, sometimes you're asked to label forces, so like these pens are resting on the table, so there's a force of the pen on the table and then a force of the table on the pen, and that's a normal contact force between those two objects. And then we have non-contact forces, and I'm sure you can guess what these are, and this is where they don't need to touch. So examples of non-contact forces are things like the force of gravity, magnetism, so in year 8 you'll have done about magnets, putting stuff in a magnetic field, making iron filings move and that sort of thing. And then electrostatic forces, which are between charged particles. So we've learnt before about protons being positively charged, electrons being negatively charged. So the forces to do with charged particles are electrostatic forces. Okay, so if we think about what we know about forces already, think of an example of a force. If I hit the table like this, my hand is exerting a force on the table, but I also feel it. I can feel it in my hand that that force has been exerted, and that's because not only is my hand exerting a force on the table, but the table is also exerting a force on my hand. And this is what's called Newton's third law. and this is that when two objects interact, they exert equal and opposite forces on each other. So the example that I used was my hand hits the table. So my hand exerts a force on the table. We could say that that's a force going down, and so therefore the table exerts a force coming up, because then it is equal and it is opposite. Let's just think of an example that you could be given. You could be given an example where you have a nail that is being hit into kind of a piece of wood, and that you've got a hammer. Terrible drawing, but oh well. If the hammer exerts a force onto the nail, which is 50 newtons, then there's also going to be an equal and opposite force of the nail on the hammer, so it'll be 50 newtons but upwards. The other thing that you can think of is if you have, because this is the one that people find tricky, so you have a person and the earth, okay? We know that there is a force pulling us towards the centre of the earth because that's due to gravity. We would call that the weight of this person, okay? So weight would be the force of the earth on the person. And most of us know this already. We encountered this in year 7. We've been talking about using the difference between weight and mass in P1 as well. So the force of the earth on the person. But from Newton's third law as well, we also know that there will be the force of the person on the earth, because the two objects, the person and the earth, are going to be interacting, so there will be equal forces but in the opposite direction. These are the questions from the 4 to 6 booklet, so either go away and have a go at them now, or listen to the question being read, have a go at the question whilst you pause the video, and then go through the answer. So make sure you've got your highlighter at the ready so you can highlight the key information. Below are 2 different types of force. One is a contact force and one is non-contact. Next to the picture below, label which one is which and a reason for your decision. So here we have a person carrying a box, pushing a chair and pulling a chair. So we should be able to see that all 3 of these, they've made contact with each object. So here they're making contact, here they're making contact, and here they're making contact. So this is a contact force because they physically need to touch or make contact to exert the force. Okay, which tells us that this one already we know is a non-contact force, but we still need to give a reason why. So hopefully we should be able to see the fact that they say N and S and N and N, it should give us a clue that they're magnets. So we've got here a north pole and a south pole with arrows going towards them, and then a north and a north. And hopefully remember from year 8 that these forces show that the north and the north would be repelling each other, so that's why the lines don't go from one pole to another. Here they'd be attracting and here they'd be repelling, so they're pushing against each other. So they're a non-contact force because a force can be exerted in the field surrounding the magnets without touching it. So, set of diagrams at the bottom. In the scenarios below, tick the object which is exerting the larger force. So we can look at these two at a time. So out of these two objects, this one's exerting the larger force because it has a bigger arrow. This one's exerting a larger force because it has a bigger arrow. And then again this one because it has a bigger arrow. So now we have a piece of information that we need to read and then some questions that we need to answer. A good tip for exam style questions is the temptation often is to kind of ignore all of this and skip straight to the questions and then go back to find the information to answer it. You're more likely to miss something if you do that. So read through the information, highlight the stuff that you think might be important, and then it should be easy to pick it out. Once you've then read the question, you should be able to find the information more easily if you've highlighted it in the question. High diving is the act of diving into water from extreme heights. In 2013, at the World Aquatic Championship, a new competition was introduced, a high dive from 27 metres. The highest dive board in the Olympics is 10 metres. From this height, dives can take up to 3 seconds, with divers reaching speeds of 90 kilometres per hour before entering the water. In this diving competition, divers enter the water feet first because of the high risk of head injury. The water stops the divers in less than a second, and they rarely go deeper than 4 metres. Okay, so we're going to use this information to then answer, or in the context of this question, we're going to answer these questions. So, name one contact force and one non-contact force acting on the diver as they are falling through the air. So a contact force and a non-contact force as they fall through the air. So if we're talking about a contact force falling through the air, we could say that the contact force could be air resistance. And the non-contact force, well, if they're falling, then we would say that it would be gravity or their weight. Because if they're falling, they're being pulled down towards the centre of the earth. So for the contact and non-contact forces you named in question 1, identify their equal and opposite force. Okay, so if we let's first go back to this question and write it out in terms of what the force is. So air resistance is the force of the air on the diver. Okay, so their equal and opposite force for the contact will be the force of the diver on the air, because it's just the opposite. If this is the force of the air on the diver, this is going to be the opposite, so the force of the diver on the air. So let's go back to this one for the non-contact. At the beginning of the lesson, when I went through the bit on the A3 paper, I said that weight was the force of the earth on the person, so on the diver. So if we want the opposite of that, then we want the force of the diver on the earth. So all you're doing is you're swapping over those two words, because it's just, you're swapping over the direction. So the earth on the diver on the earth. Okay. So name one contact force and one non-contact force as they enter the water. And then we need to do the same in the next part, identify their equal and opposite force. So the contact force as they enter the water, we could call it drag, which is the force of the water on the diver, so it's like water resistance really. And then a non-contact force, it's still going to be gravity. So the force of the earth on the diver. Oh, so we could say gravity. Okay, so this is the contact and this is the non-contact. Sorry, I should have written it the same as up here. So if we think about the opposite of the contact force of the drag, it's going to be the opposite of the force of the water on the diver. So it'll be the force of the diver on the water. And then for the non-contact, it's going to be the same, it's going to be the opposite. So in the same technique, we're going to say the force of the diver on the earth, because that is the opposite of the earth on the diver. Okay, so explain why, in terms of forces, there is a risk of head injury when diving from this height. Suggest why the divers would choose to enter the water feet first. Well, when they enter the water, there is a large force exerted when they enter the water. Okay, and as we've already said, if there is a large force that they exert on the water, there will be an equal and opposite force exerted on the diver, and it's obviously better to have that bigger force on your feet than on your head. Okay, so it's better on feet than on your head. You could also say about the fact that feet have a smaller surface area, so they'll break through the water more easily, and also that by the time, so if this is the water and they enter kind of, because they'll have their arms down like this, they enter feet first. By the time they get through the water, by the time their head touches the water, they'll have slowed down quite a lot, which means that by the time their head's going through the water, then they'll have slowed down. There's a smaller force that will be on their head then. And the last part, the summary. So forces can change the shape of an object, its motion, or its state of rest. They are measured in newtons. Contact forces can only act when objects are touching. Newton's third law says when objects interact, they exert, that's a mistake, exert equal and opposite forces on each other.